So for section 3.2, we're going to be graphing linear equations, not just, finding some points and checking points. So in this situation, we're going to be graphing a straight line. So all the equations we're dealing with are linear, and a line is going to represent all possible solutions, all possible points that we could check. They're going to start by giving us the equations, kind of like in the same form we did last time, where it's a standard form, ax plus by equals c. When they do this, what I would encourage you to do is, my favorite thing to do is just solve for y equals mx plus b, so if you're comfortable with that, please feel free. But when it's already in standard form, there are two easy points to find, the x-intercept and the y-intercept. If you remember about it, the x-intercept is where this graph is going to cross the x-axis. And in the last section, we said anywhere on the x-axis, y equals 0. So the x-intercept, where the line crosses the x-axis, y will equal 0. So I could go to this equation, and I could stick a 0 in place of the y, and that would give me the x-intercept. And so let's go ahead and do that. So I stick a 0 in place of y, and I get 4x minus 5 times 0 doesn't really matter, equals 20. So when I stick a 0 in for the x, that second part just zeroes out and goes away, and I get 4x equals 20. Divide both sides by 4, and I get that x equals 5. That is a point. 5, 0 is the x-intercept. The second point I'd rather like to find with this would be the y-intercept. That's where the line's going to cross the y-axis. That makes sense. So our y-axis up here. Anywhere on the y-axis, x equals 0. Any point on here, if I said 0, 0, 0, 0, 1, 0, 2, 0, 3, 0, 4, any point on the y-axis is going to have an x value of 0. So stick a 0 for the x. If I stick a 0 in the equation for the x, I get 4 times 0 minus 5y equals 20. 4 times 0 doesn't really matter, just zeroes out. So now I end up just dividing by the negative 5 and getting that y equals 4. So 0, hopefully you caught that. A positive divided by a negative, negative 4. 0, 1, 2, 3, negative 4. And that is the y-intercept. And 1, 2, 3, 4, 5, 0. And I like to get a third point, but I think for these, let's go ahead and just stick with this for now. If you can plot 2 points make a line. So if they give it to you in standard form, and you can find the x-intercept, which was, 5, 0, and the y-intercept, which was 0, negative 4, then you can draw a line. Let's try another one. Let's go ahead and start with the x-intercept. Remember the x-intercept, you have to remember, is where y equals 0. So I'm going to go to this equation and stick a 0 in place of y. Divide by the 2. X equals 2. There's a point. 2, 0. That would be the x-intercept. The y-intercept, where x equals 0, 2 times 0, plus y equals 4, y equals 4. 0, 4, that would be the y-intercept. Like I said, I like to get another point, so when you can, like if you've got a 2 and a 0, I could pick a number in between the two of them. I could stick in a 1 and just see that it follows a straight line. But you don't have to do this. You really only need those 2 intercepts, but just a second, I'm going to be encouraging you to graph 3 points anyway. But there is a number between this 2 and 0 that's a nice point. We could plug in a 1. 2 times 1 plus y equals 4. 2 plus y equals 4 So y must equal 2. And 1, 2 still fits along our straight line. So you get those 3 points, you draw yourself hopefully a line a little better than mine. Okay, but those 3 points fall along a straight line. Those are not the only solutions, so don't just connect those dots and then stop. They actually, every point in between them that this line falls on is a solution. All those decimals, all those scary fractions, plus on forever. So we make sure we put an arrow on each side because these solutions go on forever. What if they give you the equation in slope-intercept form, right? Now, some of you already know slope-intercept form. I still want you to write this down. I think it'll benefit you. They don't really use this yet. They're still going to have us plotting points, which I think is actually a healthy thing to do. They call it slope-intercept form because the first number that's with the x is our m, that is our slope, and the b is our y-intercept. Okay? This should make sense, and we'll talk about why this works in a second, but I'm not going to just plot a 0 for x and a 0 for y on this. Because if I plot a 0 for x, well, that's easy. That zeroes that all out. But if I plot a 0 for y, this becomes complicated to solve for. Okay? So I'm going to be picking values just for x. We're going to be plugging in values into the x. Okay? So when I do this, I want to be strategic. 0 is a great number. I stick that in, that's going to zero that out. But I've got this fraction. I've got this -3 over 2. Well, I want to plug in numbers that are going to clear that fraction. My advice, pick multiples of the denominator. Look at the denominator, it's a 2. So what if I plugged in a 2? Well, that's going to cancel with the 2. What's another number that would cancel with the 2? Well, bigger would be 4, 6, 8. Don't plug in a 3 or you're going to end up with a fraction as a y value. Not that that's not a solution, it's just not an easy point to graph. Okay? So I definitely love the 0. That's a gimme point. And then plug in 2, plug in 4, plug in 6. Any multiple of the denominator will clear out that fraction. I also encourage you, I could go backwards too. 4, 2, 0. I could plug in -2. And so this is going to give us plenty of points. What 3 would I generally do? Probably the 0, the 2, and the -2. But at least I would encourage you to have 3 points in case you make any mistakes in the algebra. So let's go ahead and plug these in. Let's start with the easy one. Start with 0. So y is equal to -3/2 times 0 plus 3. What is -3/2 times 0? Y equals 3. That was nice. By the way, that 3 is the b. That b is the y-intercept. 0, 3 is the y-intercept. That number will always be the y-intercept. Why? Because if I stick in a 0 for x and all of this goes away, y will always equal b, which will be the y-intercept. Hopefully you didn't scratch all that out, but just deep thoughts there. So that number will always be the y-intercept because when I plug in a 0 for x, I will always get whatever that number is. Let's go ahead and take a dive into the scary and try the negative. All right, I'm going to encourage you to know that a negative times a negative is a, and that the 2's can cancel. So I'm just left with +3. If you don't like that, you may do -3/2 times -2 over 1 and make that +6 divided by 2, which is still 3. Okay? So now we've got 3 plus 3, y equals 6. It is much easier when I'm choosing stuff that clear out those fractions. So that's why I say choose multiples of the denominator. We said, let's do a +2. So -3/2 times +2 plus 3. The 2's will cancel. Y equals -3 plus 3. Y is equal to 0. Well, that was lucky. We ended up finding the x-intercept, but that's not always going to be the case. But that happened this time. And just for fun and giggles, I do recommend plugging in the 4. So -3 over 2 times 4 plus 3. I'm still going to cancel that 2 with the 4. If you don't like that, make that 12 divided by 2 is 6. Doesn't bother me either way. But I'm going to cancel the 2 with the 4. So I'm left with negative 3 times 2. So I'm left with about negative 6 plus 3. So I'm left with negative 3. This should be plenty of points. The reason I recommend having more than 2 points, like I said, if any of these were off, especially when we're dealing with the negatives and the fractions, if you mess up with the algebra, one of your points is going to be off. And how do you know? It won't fit along the straight line. And so that's going to help you make sure that you've actually done the algebra right. So let's say negative 2, 0 is right there. 0, 1, 2, 3 is there. Oh, I already messed up. Negative 2, 0. There. What's wrong with me? Negative 2, 1, 2, 3, 4, 5, 6, 0, 3, 2, 0. By the way, that 2, 0 is the one that caught me off because I knew that was not going to be a straight line. And 4, negative 3. I'm feeling really good about these points. Why? They form a straight line. Technically, slope isn't coming up till our following section, but I do like to bring it up where I can. Slope, we know, is rise over run, which I am not a huge fan of. If it works for you, great. But for most of us that are struggling with graphing, that wasn't enough. So I want to encourage you to think of rise as the change in y over the change in x. You're like, well, that doesn't seem any less confusing. I know, stick with me here, okay? Look at this table. How much are the y values changing by as we go down the table? Well, as long as I choose multiples of the denominator, we have a constant change. 6, 3, 0, 3. Every time we're going down, the y values are changing by negative 3. What's happening to the x values? Well, negative 2, 0, positive 2, positive 4, they are all increasing by 2. That is our change in x. So when we get to our next section, which is specifically on slopes, I want you to see you've already seen slopes. We've built slopes in the table. The slope of this equation, based on what I see on the pattern in my table, is rise over run, change in y over change in x, negative 3 over 2. Is it right? I'll go back. Negative 3 over 2 is our slope. And the 3 was our y-intercept. That's pretty cool. So it's already in there. Some of you, and let me be clear, because some of you right now are frustrated going, I already know how to graph using mx plus b. I'm going to tell you right now that everything we graph in intermediate algebra, everything we graph in harder mathematics, the first thing we do is we plot points. Because if you don't know what something looks like, but you can handle the algebra to plot points, then you know how to graph it. You can graph anything as long as you can handle the algebra and plot points. So this is not a lesser way of graphing. It should build the understanding to help us all understand how to use y equals mx plus b. But don't think of this as like, oh boy, I can't wait. This is an example of where I have an equation in standard form. And so my first inclination would be to check intercepts. But it's a really good example to show us why really standard form is not going to be our best way to graph these. So here's the issue here, okay? If I were to find the x-intercept, and remember that's where y equals 0, and I find the y-intercept, and that is where x is 0, let's see what happens, okay? So for the, first of all, we get the x-intercept, so 4x minus 3 times 0 equals 9. 4x equals 9. X equals 9/4. I don't really feel like graphing 2 1/4 or 2.25. Now you can, and that is the value. That is the value of the x-intercept, 9/4, 2 1/4, 2.25. But you see the limitation here. if I do the y-intercept, I've at least picked one that's a little nicer at the y-intercept, so that would be, let's see, 4 times 0 for x, minus 3y equals 9, goes away. If I divide by the negative 3, y is equal to negative 3. So I could graph those 2 points and cross them and hope that I'm going to get a kind of a straight line, but this is really not my favorite go-to. So this is where I want to know how to solve this equation for y equals mx plus b. Basically solve for y. How do I solve for y? Well, inverse operations. Y is being multiplied by a negative 3, and it has a positive or being added by a 4x. So PEMDAS backwards, we move the 4x first. Beware, 9 minus 4x is not 5 of anything, right? Those are not like terms. I'll actually encourage you further. I wouldn't even write it as 9 minus 4x. You're like, why? Remember, I want mx plus b. We actually want to put the x first. And then last but not least, to undo the multiplying by negative 3, we divide this side by. And if I do it to one side, we do it to the other. Now you have two choices. This is the way I've always thought of it. Divide the whole thing by negative 3, which will kind of distribute into both of them. But I've found that my students are more successful if we just distribute the negative 3 across the addition, across each term. So what does that do for us now? Y is equal to negative negative. We'll call that positive 4/3 x minus 9 minus 3 is 3. Now I would plug points into this. What points? Well, we already said 0 is a good one. Plug in the 0. Y is equal to, what is 0 minus 3? That's our y-intercept. I wasn't trying to butcher that out, okay? So I definitely like the 0 still, right? Pick another number that's going to clear out that fraction. Like, well, it's a 3. Why don't we try a 3 and a 6? What would 3 do? Well, y would equal 4/3 times 3 minus 3. The 3's cancel. Y is equal to 4 minus 3. Y is equal to 1. That's a nice point. Another point we said we could check would be 6. So how about 4/3 times 6? The 3 and the 6 cancel, leaving me with 4 times 2. 8 minus 3. Some of you already knew that number was a 5. Like, how the heck did they know that? Well, they already start seeing the slope on the table. When we start choosing multiples of that denominator, they're going, look, the x's are going up by, and if this is a linear pattern, the y value should go up by, so the next number should be, and it was. I think that's pretty cool. How would you graph it? 0, negative 3, 3, 1, and 4, 5, 6, 5. And if I've done it right, this should cross and make a straight line. 2 more to look at. Shouldn't be too tough. We got y equals and x equals, and we've talked about this before, so if you got this from before, it'll be easy. Pick 3 points that graph for y equals negative 4. X could equal anything. Plug in a 0, plug in a 2, plug in a 3, plug in anything for x. There is no x. The y value stays constant at negative 4. So I could actually graph that by just plotting any value for x, like 0, negative 4, 2, negative 4, 3, negative 4. As long as the y value stays constant, stays whatever that number is, you'll have no problem graphing that line. What do I do when I get x equals 3? Well, right, y can equal anything as long as x equals. You're like, plug in a 2 for x. It doesn't work. 2 doesn't equal 3. 5 doesn't. The only thing that works is when x equals 3 and y could equal anything. So 3, freaking, I don't know, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Who chose 11? 3, 1, 2, 3, 4, 5, 6. 3, 12. 3, 0. 3, 8. 3 anything, right? X will stay constant at 3. And the y can equal anything. This bothers people because the y-axis goes up and down. So why doesn't the y equation go up and down? Well, one way of thinking about it, right? When y equals -4, that means the y value must stay constant. This graph does not go up and down. The up and down value stays constant. The y value, the up and down, stays constant. What changes? X. X can equal anything. When I have x equals 3, I hope that was a 3, not a -3. No, okay, good. When I have x equals 3, what stays constant? The x stays constant. X values are left and right. This graph doesn't go left and right. Why? Because the x values must stay at 3. The x values must stay constant. And that should be it for this section. So get through those. We got one more, and then we should be almost halfway done through the chapter. So keep it up.